Alright, so let's talk about how to find an inverse of a larger matrix. With 2 by 2s it's easy because you just have a little formula. So here we've got a 3 by 3 matrix, and we want to find the inverse of it. Now at this point we have no idea if there's an inverse or not. In the next section we'll learn how to tell real quickly if there's an inverse, so you don't have to go through this process. But at this point you just have to go through the process, and if it works out, then you've got an inverse. If it doesn't, then you don't have an inverse. So what you do is you copy down your matrix, and you're actually going to append to it the identity matrix of the same size. So since that's a 3 by 3, then I'm going to attach to it the 3 by 3 identity matrix. Okay, if it was a 4 by 4 matrix, then this would be 4 by 4. All right. And so what I'm going to do at this point is put this matrix in row reduced echelon form. All right. In row reduced echelon form. RREF. Okay, so we're going to convert this matrix to row reduced echelon form, and we do that like we always have done, and that is we're going to first use this leading term and leading entry and zero out those, right? And then once we zero out those, then we'll zero out this one. Okay, and then once we've got this triangle of zeros zeroed out, then we will use the Gauss-Jordan elimination to eliminate these two and this one. Okay, now I'm not going to go through that process, we've done that, but what will happen, and then finally I shall say this: you want ones down this main diagonal, but that's your very last step. Okay, so let's go through it, just because we like doing these things, right? So the first thing we're going to do is 5 times row 1, add that to row 2, replace row 2. So I'm just going to kind of work through this, and what I'll do is I'll go off screen and I'll work through the first 3 eliminations, and then you can check my work. I should say, of course, that before I do my first elimination I should get it correct. Try that again. 5 times row 1 plus -4 times row 2. Replace row 2. Alright, so I'll see you in a minute. Alright, so it was just a matter of a few seconds to finish all this work. You can follow this through if you'd like, but you'll kind of be able to see what we did here, right? So remember, we want to eliminate zeros there and there, or create zeros there, and that's what these first 2 eliminations do. And then we want to finally create a 0 there, and that's what this elimination does. All right. You'll notice here that my result from this elimination was all divisible by 4, so I went ahead and divided it by 4 to get this nice little row, which I put in right there. Okay, so there's my triangle of zeros, right? And notice, as I'm creating zeros here, this side is moving away from the original identity matrix. That little 3 by 3 matrix right there is changing. That's okay. I don't care what this does. I mean, I do care, but it's just going to happen naturally. I just got my zeros there. And remember, we do it in that order. We go this one, this one, this one, and then we're going to start eliminating above the leading terms. That one, and that one. And so that's what I've done here. Okay, right here. We eliminated these 2 eliminations, create these 2 zeros, and you can see those rows going right in there as my new row 1 and row 2. And then finally I needed to create a 0 there, and I did that with this elimination right there. And in both cases, the results I got, you can see those outlined here and here, were divisible by a number, because what I want is ultimately I want ones there, right? And it just so happened that, you know, this guy had a 4, but if I divide it by 4 I get a 1, and everything's divisible by 4. It looks good. Alright, so look, I have got this right here. So that's the process. You eliminate it to where you get the identity matrix on the left hand side. And what happens is this matrix is the inverse. Okay? What that right hand side transformed into is the inverse. 3, negative 4, 3, 1, negative 2, 2, negative 7, 11, negative 9. Okay? And so you could then check that inverse by multiplying A times this, and you better end up with the identity matrix. Okay? So let's talk technology for a second. Really, while it looks like it was pretty complicated, and it was by hand, it's kind of a pain. And this is just a 3 by 3. If it's a 4 by 4, you've got a lot more eliminations to do. But what we're doing is we are putting this matrix in row reduced echelon form. Okay, that's what we're doing. The reason I make a big deal of that is because our technology can do that for us, right? So I would just enter this matrix into GeoGebra or into my calculator, and I would have it reduced, right? And it will result in this matrix down here, which then I can just read the inverse off of. Okay. Now, that being said, with the TI calculator, well, with both of these calculators, you can find the inverse directly, and I will show you how to do that right now. How you find the inverse. It's the same process, but the calculator doesn't, show all this left-hand side. All right. So let's just take a quick look and see how we find these inverses using technology, using the two technologies that we have. So let's start with using the TI calculator. And again, I apologize that it's so small. But what we're going to do is we're going to want to enter this matrix, this 3 by 6 matrix, in to the calculator. Right? So I'm going to edit matrix A. It's a 3 by 6. And now I'm just going to enter my numbers. 4, 3, 2, 1, 0, 0. Okay. 5, 6, 3, 0, 1, 0. Hopefully these are all going in. And 3, 5, 2. 0, 0, 1. Okay, and remember, we want to quit out of this, and now I want to take a look at that matrix and make sure that it is correct. So I can go grab it, and it looks like we did it correctly. Alright, so I can find the inverse by simply reducing, putting A in row reduced echelon form, right? So I go to matrix, I go to math, and I go to RREF. Now let me mention this. You might be saying, well, why don't I just use the inverse function? Look in this menu. There is no inverse function. All right. So, but there is an RREF. So we select that, and we'll go back to matrix and grab the name of our matrix, which is A, and hit enter, and it does what? It reduces the matrix. And notice there, right there in those first 3 by 3 section, that's our identity. And over here is our inverse. Thank goodness. Okay. That being said, there is an easier way to find the inverse without row reducing. The calculator does have the ability to find the inverse, but it is not intuitive. So what you got to do is our matrix is, we need to just enter our matrix itself. So let's just enter it in B. So we're not going to enter that big, oops, I don't want that. We're not going to enter the big 3 by 6 matrix. We're just going to enter our matrix. Okay, try that again. B, oh wait, we want to go to edit, now B. Okay, so it's going to be a 3 by 3 matrix. And so the matrix we're going to enter is 4, 3, 2, 5, 6, 3, and 3, 5, 2. 3, 5, 2. Okay, quit out of that. Let's just take a quick look and make sure it's in B now. B is correct. There it is. We've got it all entered correctly, so we should be good. So how do you find the inverse of it? You can just go back to matrix. You grab the name of the matrix, B, right? Hit enter and it puts it on the screen. And then you go to the x raised to the power of 1 button. And notice it puts the exponent of -1 on there. And that's where you hit enter. And there's your inverse. Okay, so that's how you use a TI calculator to find inverses in the two ways, the row reduction method and then just the regular internal calculator command. Alright, so let's just take a quick look at GeoGebra, how this works. Remember how we enter calculators. We want to bring up the spreadsheet. So click on that spreadsheet. And we actually need our windows. We want to see all of our windows just like before. So let's get that set up. Alright, so you can get the windows you want by clicking your little 3 bars up here. Assuming we don't lock up. Yeah, there we go. Clicking the 3 bars, clicking view and make sure you have algebra selected. You don't really need graphics. In fact, we can do that, and that's gone. And then your spreadsheet. Okay, so we're just going to enter our matrix in here, and we'll go through both methods here just so we can practice. So here we go. We'll come in here and we'll say, all right, we need our matrix, which is 4. Of course, this is. There we go. Let's try that. 4. Anytime now. Enter that 4. 4. Hold on 1 second. Alright, so I've entered this matrix here. Let's see if we can get. The computer is battling me right now. Okay. Give it 1 moment here. Okay, so of course you know what you do. You select those entries and you create a matrix from them, right? That's our matrix M1. Okay. And then you're going to reduce that matrix. I think we might have enough trouble here that we might not be able to demonstrate it, but you would reduce that matrix. On the other hand, you could just enter the matrix itself and create the matrix from that matrix, just like before. And that's M2. And let's just see if we can do this. I don't know about this. So if you want to find the inverse of it, you're going to start typing in inverse, and it's invert. So invert is the command, and then we want it to invert M2, and we hit return, and there it is, right? M3 is the invert or the inversion of M2.